Good morning, my dear students. Hope you are doing well. Today I'm going to continue the explanation of Chapter 20, Oxidation Reduction Reactions. The objectives that you are going to learn during this session are three. The first one is to define oxidation numbers. The second one is to assign oxidation numbers by using the general rule. The last one is to identify oxidation and reduction half reactions for redox reactions by using oxidation number. First of all, let us have a revision of what we have taken in the previous session. I will ask you questions from your daily life. The first one, why do fireworks have a bright light when they are burned? Because fireworks contain powdered metals, magnesium or aluminum, that react with oxygen. The second question, what do you call this reaction? It is combustion reaction. The third one, does the metal lose or gain electrons when it reacts with oxygen? The answer is it loses electrons. The fourth one, what do you call the reaction where losing of electrons take place? It is oxidation. So what is oxidation? Oxidation is the complete or partial loss of electrons or gain of oxygen. What is reduction? Is the complete or partial gain of electrons or loss of oxygen. The reaction where oxidation and reduction take place is called redox reaction. Now, let's start with the first objective. Define oxidation number. What is oxidation number? Is the number of electrons gained when the element is reduced or the number of electrons lost when the element is oxidized. So the number is preceded by positive or negative sign as +1 or -1. What is the difference between a charge and an oxidation number? Let's see here. A charge is written as 1 plus, 0 or 1 minus, but an oxidation number is written as +1, 0 or -1. Let us take an example. Na plus Cl2, it gives NaCl. Observe here the Na. Na is sodium atom that has a charge 0 and its oxidation number is also 0. 1. It becomes a cation, Na+, its charge is 1 plus and its oxidation number is +1. Similarly, for chlorine, Cl2 molecule, it has a charge of 0 and oxidation number 0. When it becomes an anion, Cl-, its charge is 1 minus and its oxidation number is -1. Now the second objective is rules for assigning oxidation numbers. Let's start with the first rule. The oxidation number of a free element is 0. Example, Na solid is an atom. It is a free element. its oxidation number is 0. Similarly, for Fe solid, the oxidation number is 0. For Cl2 molecule, it is also an element that consists of two atoms of Cl, so its oxidation number is also 0. Similarly for H2 gas and O2 gas. The second rule is the oxidation number of oxygen in a compound is equal to -2. Example, H2O. Here the oxygen in H2O has an oxidation number of -2. The same for MgO. The oxidation number of oxygen in MgO is -2, and the same thing with sodium oxide. Its oxidation number is a -2. As usual here in chemistry, for every rule there is exception. So the exception here is when oxygen is in peroxide compounds such as X2O2, its oxidation number is -1. Example, H2O2, it is hydrogen peroxide, the oxidation number of oxygen is -1. Sodium peroxide, Na2O2, the oxidation number of oxygen here is also -1. Now let's move to the third rule. It is the oxidation number of hydrogen in a compound is equal to +1. Example, let's take also H2O. The oxidation number of hydrogen in H2O is +1. Similarly, for HCl, the oxidation number is also +1. The exception here, 1. Hydrogen is forming a compound with metal, its oxidation number is -1, and its name is metal hydride. Let's take an example. NaH is sodium hydride. The oxidation number of hydrogen is -1, and CaH2, which is called calcium hydride, the oxidation number of hydrogen is -1. The fourth rule is that the oxidation number of a monoatomic ion is equal in magnitude and sign to its ionic charge. An example is Br minus, its oxidation number is -1, so it is equal to the magnitude and sign of its ion. Now the same thing with Fe3 plus, so its oxidation number is +3. Now let's move to the fifth rule. For any neutral compound, the sum of oxidation number of the atoms in a compound must equal 0. Example, let's take H2O, oxidation number of hydrogen is +1, oxidation number of oxygen is -2. Add these two oxidation number, +1 times 2, because we have two hydrogen atoms, so it will be +2 for the oxidation number of oxygen, -2. Add these +2 -2, it will be equal to 0. Similarly, for HNO3, here the oxidation number of nitrogen is unknown. We have to calculate it. In order to calculate it, we'll use the rule, which is +1 for hydrogen, +X for nitrogen, +3, since we have 3 atoms of oxygen, times -2 equal to 0. Solve for x and we'll get plus 5. Therefore, the oxidation number of nitrogen in this compound is plus 5. Let's take the HNO2, which is nitrous oxide. What about the oxidation number of nitrogen here? We apply the same rule. The sum of the oxidation number equal to 0. So we'll get here plus 1 for hydrogen, plus X for nitrogen, plus 2 because we have 2 oxygen atoms. The oxidation number of each one is minus 2, so you multiply it. 2 times minus 2 equal to 0. And you solve for X, you will get plus 3. Therefore, oxidation number of nitrogen in this compound is plus 3. What is the conclusion? Oxidation number of the same element in different compounds can give several different oxidation numbers. Now, the sixth rule is for a polyatomic ion. What do you mean by polyatomic ion? Let's see here. For example, nitrate NO3 1 minus polyatomic ion are groups of atoms that stay together and have a charge. So, for a polyatomic ion, the sum of the oxidation number must be equal to the ionic charge of the ion. Example, SO4 2 minus. The oxidation number of sulfur is unknown. We have to find it. The oxidation number of oxygen is minus 2. So solve for X. You will get here X plus 4, since you have 4 atoms of oxygen, into minus 2 equal to the charge of this polyatomic ion, which is minus 2. Solve for X and you will get X equal plus 6. So it means that the oxidation number of sulfur is plus 6. Let's take another example, SO3 2 minus, which is sulfide ion. We have to solve for X in order to find the oxidation number of sulfur, and we get here X plus 3 into minus 2 equal to minus 2. Solve for X, you will get X equal plus 4, implies the oxidation number of sulfur is plus 4. Let's take a dichromate ion, which is Cr2O7 2 minus. The oxidation number of the Cr is unknown. We have to solve it. Here you have how many atoms of Cr is present in this polyatomic ion. They are 2. So you multiply 2 by X. So you will get 2X plus oxygen. You have 7 atoms of oxygen, so 7 times minus 2 equal to the sum of the charge of this ion, which is minus 2. So to solve for 2X, you will get minus 2 plus 14, and the X here for 1X, it is plus 12 over 2, implies X equal plus 6, and the oxidation number of Cr is plus 6. Now let's have the 7 rule, which is in a chemical reaction, if the oxidation number of an element is changed from the reactant to the product, this reaction is called redox reaction. Example, Na solid plus Cl2 gas, you will get NaCl. Let's observe here the Na, it changes to Na, Na in the compound NaCl. So Na here is oxidized. Observe the oxidation number of the Na is 0, it becomes +1. So the oxidation number here increases. So Na is oxidized, it undergoes oxidation. Now let's take Cl2, the oxidation number is 0, it becomes in the product -1. So the oxidation number decreases. So Cl undergoes reduction, or Cl is reduced. So here we can also try to compare the oxidation number of the same element in the reactant and the product. Again, if the oxidation number increases, the element undergoes oxidation. It is oxidized. We say it is a reducing agent. Cl, its oxidation number decreases, so the Cl undergoes reduction. It is reduced. It is called oxidizing agent. Now the last rule is, in a chemical reaction, if the oxidation number of an element is not changed from reactants to products, the reaction is called non-redox reaction. Let's take an example. NaOH is a base, strong base, plus hydrochloric acid, strong acid, it gives NaCl plus H2O. Let's compare the oxidation number of Na in NaOH and in NaCl. They have the same oxidation number, which is the +1. Also, let's compare the oxidation number of Cl in HCl, the oxidation number of Cl in NaCl in the product. They have the same oxidation number. Conclusion here, no change in oxidation number implies the reaction is called non-redox reaction. So, redox reactions, what's the meaning of redox reaction? Red for reduction, ox for oxidation. Now let's move to the third objective, which is identify oxidation and reduction half reactions for redox reactions by using oxidation number. Here we have an experiment. The beaker, it contains, we put in the beaker copper wire, we dipped it in a silver nitrate solution. What we get, a redox reaction occurs. Now let's see the observation. Here we have crystals of silver coat the wire in figure B. This is the change. Crystals of silver coat the wire. The second observation, the solution turns blue due to formation of copper to nitrate. Now, how do you write the oxidation reduction half reaction? We have the Cu, which is the metal wire. It loses 2 electrons and becomes Cu2 plus. The reduction half reaction, the Ag plus in the solution of Ag and O3, it gains 1 electron and it becomes Ag silver that surrounds the copper wire. Now here in order to add the two equations and to get overall reaction, we have to multiply the reduction half reaction by 2 in order to get 2 electrons gained, and in oxidation half reaction 2 electrons lost. Now we can add the two equations and you will get Cu plus 2Ag plus, it gives Cu plus 2Ag solid. Conclusion here: an increase in the oxidation number of an atom or ion indicates oxidation. A decrease in the oxidation number of an atom or ion indicates reduction. Let's take an application here to understand the objective well. The above figure shows what happens when iron nail is placed in a solution of copper 2 sulfate solution. Now observe figure B. In what happens when we put the iron, figure A, what happens when we put iron in copper 2 sulfate, the observation in figure B, the iron becomes coated with metallic copper. And the blue color of copper 2 solution becomes green due to formation of the Fe2 solution. Now the oxidation half reaction is Fe loses 2 electrons and becomes Fe2 plus. Reduction half reaction, the Cu2 plus in the solution gains 2 electrons and it becomes Cu solid. Now the number we observe here, the number of electrons lost equal to the number of electrons gained. So we can add the two equations and we have the overall reaction, which is Fe plus Cu2 plus. It gives Fe2 plus Cu. Now let's remember together also, what do we call Fe? Fe is called reducing agent. What about Cu2 plus? It is called oxidizing agent. So, and now here, I want to ask you a question, but first I want to review with you the reactivity series or activity series of metals. Do you remember here that metals, some metals are more reactive than others? And we start with potassium in column 1, sodium in column 1 also, and we move to column 2 and to the other metals. We say here, as you go down, the reactivity decreases. So let's compare here. What do we want? The Fe and the Cu. Which one is more reactive? It is Fe. Okay, now let's see here the question. What would happen if a copper nail were added to a solution of iron 2 sulfate instead of iron nail in copper 2 sulfate? Do you think that we have a reaction? Let's think about it. The answer will be no, because nothing would happen, because copper is below iron in the activity series of metals. Okay, now the last thing, we are going to take an example or an exercise. Determine the oxidation number of each element in the following: S2O3. Let's solve it together. We have here the S is X, the oxidation number of oxygen is -2. Solve for X, which is here because sulfur has consists of two atoms of sulfur. We'll get 2x minus 6 equals 0. Solve the equation here. You will get 2x equal plus 6, and for 1x it is plus 3. Now part B, you have sodium peroxide. You have to remember the rule of peroxide, of the peroxide here. In this case, the oxidation number of oxygen is -1, and the oxidation number of sodium is a +1, so the sum of them is also equal to 0. Now let's take part C, which is P2O5. It is phosphorus, diphosphorus pentaoxide. The oxidation number of P phosphorus is X, and the oxidation number of oxygen is -2. So you solve here 2x plus 5 into -2, the sum of them equal to 0, and you can calculate for x. 2x equal plus 10, so for 1x is plus 10 over 2, and it is equal plus 5. If we take a SO3 2 minus, it is carbonate ion. As you know here, it is polyatomic ion. The oxidation number of carbon can be determined by the rule where the sum of the oxidation number of polyatomic ion is equal to its charge, which is 2 minus. So X, which is for the carbon, plus a 3, this is 3 for the oxygen that has 3 atoms of oxygen, times -2 equal to -2, implies X equal -2 plus 6, and the oxidation number of carbon is +4. I hope that you are interested in this lesson. Thank you.